evening. Happy Thursday. Welcome to your Thursday evening stroll around your celestial neighborhood. I'm Irene Pease, your friendly neighborhood astronomer, coming to you from the past. Just a quick note, this is a recording. I'm recording earlier in the afternoon on Thursday because I have an in-person event that I'll be at 8 p.m. So hopefully you can still tune in or check it out at a later date or time to help you get ready for the Perseids meteor shower, because obviously it's that time of year. So I'm going to be looking at the Perseids meteor shower for 2021 tonight. So as usual, I'm going to be using visuals from OpenSpace, which you see in the background now. You can find and download OpenSpace for free at openspaceproject.com. And tonight I'm also going to be using a little bit of Stellarium, which you can find and download at stellarium.org. Put it on your desktop, put it on your device, all the things. So yeah, I mentioned that it's that time of year for the meteor shower. So let's go ahead and take a look in Stellarium, see what that could look like for us. So I have the time set just for our regular 8 p.m. On today. So even tonight, you might be able to start seeing some Perseids. It actually lasts for quite a while, over a month really, from mid-July to mid-August, kind of July 17th to about August 24th. And it's usually one of the best and brightest meteor showers. So we rank meteor showers by how bright they are, how easy they are to see, and how many meteors per hour you might be seeing. So if you play with Stellarium a lot, or if you watched these before, you'll notice that Stellarium does have a meteor shower feature. So we can see some other current or upcoming meteors. So this one is going on right now, the Capricornids, which have a whole number per hour max of about 5. So if you lay out for a whole hour, you might see 5 of those. Fortunately, there's other meteor showers happening right now. There's the Southern Aquarids. So also viewable, but really what we want to get to tonight is the Perseid. So if we just take a look, like some of these others, 7 to 8, 16, not too bad. Southern Delta Aquariids, 5-ish. So if you're seeing single digits, it's probably not worth it to go out for just that meteor shower unless you're like a huge meteor shower fan. When you have a collection of meteor showers kind of happening all at once, even if it's not the peak, then that's still pretty good. But right now we have a few of those, and then we also have the Perseids, and you notice the Perseids has a huge count, 100 max. So don't expect 100 full meteors per hour, but you can expect over 40. So usually between 50 and 100, which is a huge range, but it is going to vary a bit from one year to the next. So another thing that determines how great the Perseids or any meteor shower is going to look from one year to the next is the moon phase. So if you look around, you notice here we are, midnight. There's no moon up yet. So we're not going to have a moon till a little bit, whole lot later. So the moon is actually in a really good phase this year. Sorry, that's not actually the moon. There we have the moon. Really good phase this year. So that's really helpful. So if we don't have a very bright moon out during the peak time of the Perseids, that's our best option. So I'm just going to go ahead and rewind this, because really the best time to view the Perseids is going to be maybe as early as 10 p.m. and then as late as like 4, or basically until the sun comes up a.m. My peak time that I usually aim for is between midnight and 2 a.m. So if I just put this at 1 a.m. and we just kind of pan through, we'll notice that even though tonight's not the peak, right? The moon is 27 and change days old, so it's almost new. It's very, very old. So as we cruise through here to the 12th So really the night of the 12th to 13th, so kind of in here, we have a young moon, but it's going to be setting early in the evening, right? So that is not going to be disturbing our late night or very early morning viewing of the Perseids. So this makes 2021 a relatively good year for the Perseids meteor shower. So what I wanted to talk about a little bit is, why is the marker for the Perseid over here? This marker is called the radiant, so that's the point from which the Perseids seem to radiate, hence the word radiant. So you notice these other markers are in other constellations, and basically the meteor showers are named after the constellations in which they appear, right? So the Aquarids have radiance in Aquarius, the Capricornids have a radiant, well, near Capricornus, and the Perseids have a radiant in the constellation Perseus, with this nifty star Algol, which I think I may have talked about, but if I haven't, I should at some point because it's cool. So why do the meteors appear to streak from that part of the sky? And why is the best time to view it at 1 o'clock in the morning? Like, if it's coming from this part of the sky, wouldn't we want that to be highest up, right? Because usually when we're looking at objects, the best time to see them is when they're crossing the meridian. That's that line that runs from due north to due south and passes through the point overhead, the zenith. So normally, like if I'm trying to look at Altair, this lovely star Altair, say, I'll want to do it when it's really high, right? So maybe around midnight next week. But we don't necessarily want to view, the best time for viewing the meteor showers isn't necessarily when the radiant is highest in the sky. And to get kind of a better sense of what's going on with that, I'm going to flip back over to open space and kind of take a look at what's happening in our solar system with this in 3D. So here in OpenSpace, if you're not familiar, this is basically software. It's open source software in which you can import any data that you want. So there's a whole bunch of data sets that come with it, all kinds of orbits and positions of celestial bodies, the planets, moons, some asteroids, comets. And it's all real data, and then you can also add your own if you want. So pretty much everything you're seeing here is like how it would look if we were flying around in 3D space, except these lines wouldn't be there. So we have some artificial markers like helping us see the orbits of the planet. So you see the orbit of Earth that we're moving away from. And then inside the orbit of Earth, we have Venus and Mercury. There's the sun. And then this kind of golden streak out here, that is the orbit of Swift-Tuttle. So why do we even see meteors, aka shooting stars? So as they might be giants, as in the song, forgot the name of the song, but a shooting star is not a star. It's not a star at all. It's usually bits of comet debris, so dust and bits that enter our atmosphere and burn up. And so if you've seen some of the presentations I've done about stellar streams, we know how there's these streams of stars that extend on either side of the galactic plane, and we can trace those streams of stars, so to speak, back to either interaction events of like small dwarf galaxies with the Milky Way, or some of them we trace back to globular clusters that have passed through the galactic plane and they get tidally stripped. So there's material that comes off of them and then is still orbiting in that same path. Well, the same kind of thing, similar kind of thing happens with comets. So a lot of our comets come from really far out. So you can see all the way out beyond the orbit of Uranus and Neptune. So this is, you can see this line is Uranus in here and this line is Neptune. So out beyond that, we have the Kuiper Belt, and even further out beyond that, we have this theorized group of objects called the Oort cloud that we haven't directly observed, but we think that's what where a lot of our long period comets come from. So the trail of dust and debris that we pass through that caused the Perseid meteor shower, we've traced that back to the comet Swift-Tuttle. And this is the orbit of comet Swift-Tuttle. So you can see it's come up above our solar system plane. This is the north side of the plane. This is the south side of the plane. And then down towards the south and stringing around there. So it takes about 133 years to make a complete orbit. So it was observed back in 1992. That's the last time it came in and made a nice close pass around the sun and right past Earth. Well, Earth's orbit anyway. We weren't necessarily there at the time. We may have been in a different location in our orbit when it made its pass. The next pass will be in 2162, so if you're waiting around for that, you could be waiting for a while. But it's just a little comet, about 16 miles-ish in diameter, and all this stuff that it's leaving behind in its trail comes from the tail of the comet. So if you're familiar with comets, you know they actually have two tails. So as a comet is moving in its orbit around the sun, right? If this is the direction of the sun's solar wind is going to knock off a lot of these lighter particles. So there's a gas or ion tail that's the very, very light particles, basically gas particles and ions from the main part of the comet, we'll call the nucleus. So those are always going to point directly away from the sun because they're very, very low mass. They're very light. And then there's also a dust tail, and that's what we care about tonight, is this dust tail. So again, as the comet gets closer to the sun, like inside of the orbit of Mars or so, that's kind of our ice line for the solar system. That's where ices will start to not melt per se because it's space, so there's low pressure, so it's more like they sublimate and become gases, and so they go basically right from solid to a gas phase. But that ice line where that happens is kind of around the orbit of Mars or so. So we'll get ices, and when we say ices, we don't necessarily mean just water ice, but it could also be dry ice like frozen carbon dioxide or ammonia or other things like that. So the lighter stuff gets pushed directly away from the sun by the sun's radiation, but then the dust, these are going to be heavier particles. And when we say dust, we're talking about tiny, tiny clumps, like sand-sized particles, like 100 atoms or more generally. Those have a little bit more mass, so they have a little bit more inertia. So they're still kind of going in the direction of the comet, right? So the comet here is going kind of down and to the left. This beautiful picture from NASA. Thanks, NASA. So the comet's going this way. The sun is pushing on stuff that way. So the dust tail kind of gets pointed off in a slightly different direction. So both tails point more or less away from the sun, but the gas tail points exactly away from the sun. Usually the more prominent and brighter dust tail points a little bit back in the direction that the comet just came from if it's coming inward, and actually it will lead the comet as it's leaving because it'll still be away from the sun. But maybe we'll do a whole nother thing on comets to get more into that. Said all that to say that all this dust and stuff, it doesn't just sit there, right? It's still orbiting the sun. So all that stuff is going to be in kind of a ring of debris after multiple passes. I mean, this thing didn't just pass once. It's been passing, over the millennia. It's been going around in this orbit. So there's all this dust from every time that it comes by and gets heated up by the sun. So lots of little dust particles that are stringing around. And we can see as we come in, so we'll be looking down from Earth's north pole. So we can see that this is the path. So above, or I should say on the north side of the solar plane of the solar system, and then towards the south side. So it actually would be hitting Earth as Earth comes along here right now. This is set for August 3rd. But we'll just go ahead and kind of turn on time here and see August 3rd, August 4th, 5th, 6th, and see the Earth kind of plowing towards where this stream, like gushing like a waterfall. Think of it like we're going to run through this waterfall that's kind of pouring down onto kind of the northern hemisphere. And also, if you just kind of zoom in towards Earth a bit, so this is August 11th, and then August 12th, 13th, we just kind of passed right through the waterfall. So why is it seem to come from that direction of the sky? Well, if we just run back time a little bit, right? So before we pass through the waterfall, if we try to get in a little bit closer and then kind of look at the direction that it seems to be coming from, see if we can find our waterfall stream thing. There it is. Yeah, so it seems to be kind of coming from up in this direction, right? And what constellation do you think is up in that direction? I don't know. Let's see. Yeah, there's Perseus. So as we're passing through the waterfall, it seems to be streaming down from the direction of Perseus. And you'll also notice that we're running into it with like kind of the night side of Earth. And so that, again, that's why it's best viewed at that time of night. So you want to be looking up when this kind of stream of stuff is hitting, intersecting with our atmosphere. So even though they're just kind of tiny little particles, they're all pretty darn small, like grains of sand. Then we're really only going to get even though there's these grains of sand, we still see like these nice streaks across the night sky. So yeah, so if we pop back over to stellarium, yep, that's the stellarium. Again, we're seeing that's the radiant point, right? So we can imagine that's the point from which the shower is kind of spraying. So we can see them all over the sky. I'm going to go back to our 2 a.m. so it's a little bit higher. So you can see them all over the sky. It's not like you're only going to see them in Perseus. You can see them way over here by Vega or Altair. Oh, look, it's that summer triangle that I said we were going to revisit. So you could see them over by the summer triangle, but they'll be streaking as if they came from this direction. So if you see a meteor going like this up kind of towards Vega, like from south to west, that didn't come from one of the Perseids. That may be one of the Aquarids that you're seeing. But if it seems like if you see the direction that the meteor is going and you trace it back and it looks like it came from this spot in Perseus, then it was probably a Perseid. So again, you don't have to be able to see the constellation Perseus in order to see the meteor shower, but it can be handy to know what to look for. If you are familiar with the Pleiades little group of stars, sorry, it's not a constellation, but it's an open cluster in the constellation Taurus, that's going to be rising over in the east. And Perseus kind of reminds me of like a big old witch hat, if we just put up the outline for it, right? So no, not adding too much imagination to it, but just this kind of giant witch hat that points up towards the brighter W of Cassiopeia. It's kind of squiggle on its side at this time of the morning. But yeah, that's the region by Perseus, so you can look for that. It'll also be just above the horizon from a bright, bright star, Capella. So that'll be up there. You'll also, if you're out viewing them, you'll have the planets. So we have Jupiter and Saturn high towards the south. And as I mentioned last week, there's some faint constellations up here in the summer triangle that you might want to try to look for. So while you're looking up, go ahead and pick out the summer triangle again. So last week we said that was Deneb in this constellation Cygnus, the swan, and Vega from Lyra, the harp, and Altair in Aquila, the eagle. So inside of that triangle are actually two more smaller, lesser known, because frankly they're not very bright, constellations. So there's Sagitta the arrow, cute little arrow thing, and Vulpecula the fox. So if you're able to pick out just kind of these stars, like I often look for a deep sky object, the Dumbbell Nebula. So I find that by kind of tracing my way from the far star in Lyra, right? So there's like a little triangle with Vega, and then this other star, I don't know why they left that one out, and then a little parallelogram. That's where the strings of the lyre are, I guess. So from Vega to this farther star, that's apparently Gamma Lyrae. So from Alpha Lyrae, that's Vega, to Gamma Lyrae. If you keep going, basically past Alberio, over in here, then you get to kind of this region really between those two constellations. But if you can find Alberio, so that kind of points you a little bit towards Alberio, and then the next star kind of to the south of that, a little southeast, is going to be one of the brighter stars of Vulpecula. So a very faint constellation, but if you can pick out at least one of the stars, great. Sagitta, a little bit brighter. So again, basically looking between Alberio, kind of a bright double star in Cygnus, that's the head of the swan, and then the brighter star Altair and Aquila the eagle, and that's kind of taking you past some brighter parts of the arrow, in addition to, I think it's the brightest star, that's Gamma up there. So see if you could pick out some of these bright stars, even if they don't look a whole lot like the shapes. I mean, Sagitta does actually kind of look like the arrow. I'm not sure how Vulpecula is supposed to be a fox, but okay. But yeah, just see how many stars you can actually see in there, because you do want to try to find as dark of a sky as possible. So always safety first. But that said, the best way to view any meteor shower is to go to a place where the sky is dark and where you have a low horizon so you can see as much sky as possible. If you have lots of trees and stuff obstructing your view, then that's just less sky and probably fewer meteors that you'll see. And you don't want to stand and look out, right? Because you'll see this much sky, right? You want to see as much sky as possible. So you want to lie back and look up. Don't stand and look up because your neck will hate you in the morning. But I like to bring just a blanket out to lie on, maybe a pillow. You can get like a reclining chair, some of those like lawn type chairs that fold up and travel real easy to a darker site, and look up and see as much of the sky as possible. So again, if we're trying to see as much sky as possible, we don't want to limit our view by looking through binoculars or a telescope. So if you don't have binoculars or a telescope, you're okay for viewing a meteor shower. I like to bring maybe just a pair of binoculars in case I want to check out a fuzzy spot or see if I can pick out, oh, look, there's these bright stars of Sagitta. Maybe there's some cute little fuzzy spots in there. But yeah, otherwise just bring, I usually recommend bug spray because I get eaten alive by bugs. If you're out early in the evening or just before dawn when the bugs are out, bring bug spray. Bring a buddy because it's more fun, maybe a warm beverage or a snack, and just a blanket or a chair to make it more comfortable so that your neck doesn't hate you in the morning. So that's our little primer for for the Perseids for 2021. Thanks so much for tuning in. I expect to be live again next week with more fun things. We'll go exploring who knows what. I guess I'll figure it out, whatever I'm in the mood for next weekend. But yeah, thanks so much for tuning in. Again, I'm Irene Pease, your friendly neighborhood astronomer. You can check out more of what I'm doing at friendlyneighborhoodastronomer.com. And of course, again, if you're interested in any of the visuals that you've seen tonight, you can check them out as well. So OpenSpace, you can find and download for free at openspaceproject.com. And you can find Stellarium at stellarium.org. Clear skies, everyone. Be safe out there. And if you haven't and you can, please go get vaccinated.